Now, before we start factoring these polynomials, we have to remember a couple of things. One is how to factor a quadratic, like we did in warm-up, all right, using the X method. Another thing we have to remember, if you want to flip your notes over to the back side and you see the middle blank space, you can just write this there. I know this is where we're eventually going to be taping down, but that's all right. So, does anyone remember, that's not showing up very well. Does anyone remember how we could possibly factor this? Yes, difference of squares. A squared minus b squared can be factored into a plus b times a minus b. Or as an example, let's do x squared minus 9. What can that be factored into?
Oh, that 18, negative 18, 27.
Nope.
X.
So in order to find a and b, the actual a and b values, what do we do to a squared and 9? Yes.
Then you can take the square root of 9.
Ah, exactly. You square root both. So what's the square root of x squared?
X cubed.
X. And what's the square root of 9?
81.
3.
Oh, square root.
So x squared minus 9 can be factored into x plus 3 and x minus 3. What about, say, 4x minus 16? 4x squared, no, let's not do 16. Let's do 25. What can that be factored into? So we take the square root of both. What is the square root of 4x squared? 2x. And what's the square root of 25? 2x plus 5, 2x minus 5.
That is so easy for someone. That's all we have to do.
Well, that's what we have to remember from previously this year. Difference of squares. Now also, I don't know if you did this year, but we do need to remember how to do it. Say I wanted to take the GCF out of these three terms. What would I do? 1. What else? X squared goes into all three. Now, remember, when we say pull out a term, pull out a GCF, what operation is that actually? Division. So I want to pull an x squared out of everything. When I am dividing exponents, terms with exponents, what do I do with the exponents? What is x to the 7th divided by x squared? X to the 5th. What did you do to the exponents?
You divide minus subtract.
Subtracted them. Just subtraction. So when you're dividing exponents, you're dividing variables with exponents, you subtract the exponents. So we did 7 minus 2 and got 5.
So then the next one is the x.
So what is 3 minus 2? X to the first power, which is just, and what is 2 minus 2? 0. What is anything to the 0 power?
0.
No. 1. Right? X squared divided by x squared, it's just dividing itself. Anything dividing itself is 1. X squared divided by x squared is 1. Do you guys remember dividing variables with exponents?
What if there's numbers there?
If there's numbers, good question. So say there was a 2 here, and there was a, oh no, let's do this. Say there was an 8 here, and then we were dividing out a 2x. Okay, So I'm dividing out a 2. 8x to the 7th divided by 2x squared is 4. 8 divided by 2, you actually divide, and it becomes 4. 2 divided by 2 is 4 divided by 2 is. So that's how that would change that problem. I divided out a 2x squared.
And you also subtract.
Then you always subtract the exponents. All right. Hopefully, us reviewing these two concepts helps us when we're factoring next. So go back to the front. Now, I don't have the front, I didn't copy and paste it in here, but this very first tab, what does the front of it say? Thank you. So you have the front, it looks like this, and I think it says sum/difference of 2 cubes. The front, flip it over, Naya.
Sum and difference of 2.
All right. We use sum and difference of cubes we use it when we, and now you're writing this in yellow, use when we have 2 perfect cubes.
Does that mean they have like 2 of the same cubes?
What? That's a good question. What is a perfect cube?
2, 3.
No.
6.
No.
All sides
Okay.
are equal.
What is a perfect square?
All sides are equal.
16 is an example of a perfect square. Give me another example. 30,
2. 42.
36,
48. 72.
4,
100.
100.
72. 50. 200.
How are we getting these perfect squares?
They're whole numbers. So it's going to be like 8.
Yes. So how do we get perfect squares?
Sorry.
I was asking for perfect squares.
Divide by 8. 4. Divide by 2.
We're multiplying a number times itself. So 2 times 2 is,
4.
that means 4 is a perfect square. 3 times 3 is, that means 9 is a perfect square. 4 times 4 is, that means 16 is a perfect square. So knowing that,
8 times 8 is 64.
what is a perfect cube?
64.
64. Why?
Because it's 8 times 8.
That's a perfect square. Good. So now, how can we find perfect cubes?
9.
Add another number. So 2 times 2 times 2 is
27.
8. So 8 is a perfect cube. 3 times 3 times 3 is 27. So 27 is a perfect cube. 4 times 4 times 4 is
20. Well, 42.
bigger.
Wait, 4 times 40.
4 times 4 times 4. 64. These are perfect cubes. So I'm going to write down the perfect cubes here. 1 times 1 times 1 is
1, 3.
2 times 2 times 2 is 8. 3 times 3 times 3 is
27.
4 times 4 times 4. And 5 times 5 times 5. 125. And also, so it keeps on going up further, but also x times x times x is, x cubed is also a perfect cube. If you think you're going to forget how we got these numbers, 1, 2, 3, 4, 5, x. I would probably write down what each one of them corresponds to. Okay. So, there are 3 types of factoring we're going over today. Well, we'll probably have time for 2. There are 2 types we're going over today. One of them is when we have 2 perfect cubes. For example, where is it? There it is. For example, we have x squared plus 125. I'm sorry, x cubed. Is x cubed a perfect square? Perfect cube. Jesus. Is x cubed a perfect cube?
Yes.
Is 125 a perfect cube?
Yes.
So I can use sum of cubes. And I'll tell you what the formula is. It's a formula. We have a cubed plus b cubed is equal to a plus b times a squared minus a times b plus b squared. This is the formula we will use every time we're trying to factor two perfect cubes that are added together.
All right, cool.
Now the trick here, the only thing you have to do besides plugging terms in is you have to find out what a all by itself is. So if I have x cubed plus 125, do you think my a value is x cubed? It's x. What did you do to get that original x? It's called blank rooting.
Square.
Not square rooting. We're dealing with cubes. We're cube rooting. To get a, you have to cube root that first term. And to get b, you have to cube root the second term. So that's our first step. We have to cube root both. So our a term here is the cube root of x squared, x cubed, which is what? What is the cube root of x cubed? X. Cube rooting and cubing are opposite operations. They cancel each other out. So I'm just left with x. What is the cube root of 125? 5. Now, if this is a bigger number than you're comfortable with cube rooting in your head, you can always use your calculator. Which my calculator is not popping up, so that's great news. Does anyone know how we would use this in our calculator? What do you have to press to cube root? Why is it not? There we go. So you press math, and then what do you press? To cube root. I don't know. Take a look, maybe.
I can't see that.
So you could press 4 or 5. 5 I would use for anything larger than cube rooting. There's a specific button for cube rooting, which is number 4. I would press number 4. So cube root 125, and it gives you 5.
550 cube root 729.
It's not a perfect cube. It'll give you a decimal, I believe.
728.
Okay. So now we're going to take this a and b values and do what with them, you think? Plug them into our formula. We're trying to factor this. So I'm going to plug a in first. That's what comes up in our formula first. My a value is x plus my b value, which is 5. Then it's a squared. What is a squared? Minus a times b. What is a times b?
5x.
Nope, just 5x. A times b is just 5 times x. We cube rooted it. So it went away. And then we have b squared. What is my b squared? Right, 5 times 5, which is 25. Now, which one of these could maybe be factored further? Do we know how to factor quadratics? Yes, that's why we reviewed it in warm-up. Now I'm going to tell you, this one does not factor. Can we think of a number that multiplies to be 25 but adds to be negative 5?
Yes.
You can. Oh.
What's it?
Multiplies to be 25 but adds to be negative 5, right? This would be the top of our x. This would be the bottom.
5 to 10.
Multiplies to be 25 but adds to be negative 5.
Oh, it's not possible.
It's not possible.
I can find a way.
It's impossible. This is our answer. Why is that so big?
Because it's impossible.
So this is as factored as this problem gets.
Wait,
All right.
why again?
Why what?
Why is that just it?
Okay, so we could try to factor this further, right? Factor a quadratic, how we know how to factor a quadratic. You put 25 up here and negative 5 down here. Is there numbers that multiply to be 25 but add to be negative 5? No. So we can't factor it. This is as factored as it gets. If it had asked us to solve this, how would you solve this quadratic?
By combining like terms.
You use the quadratic formula. Thank God it's not asking us to solve it, right?
I used to ask him to ask us to solve it.
Yes, but today is not solving. Today is factoring. All right, you guys go ahead and try this number 1. Remember, the first thing you do is cube root both terms. All right, so what did we get as an answer for number 1?
Hold on, I'm almost there.
Okay. What do we get?
Okay, I got it. It's the full equation.
Yes. X plus 2.
Minus 2x.
And then? Yes, exactly. Does x squared minus 2x plus 4 factor further? Does anything multiply to be 4 but add to be negative 2?
I got that answer. Wait, I didn't get 4. How did you guys get 4? No.
2 squared. B squared. 2 squared. Right? Our A value here was x. Our B value was 2. All right. Over here. I'm going to do number 2 with you guys. So first thing I'm going to do, I'm going to write down your formula, which is the exact same thing, except 2 of the signs are flipped.
What is so confusing?
So look. This was the sum of cubes, because it has a what between them?
Negative and positive. Positive.
The original has a plus. This one has a minus. So when you're subtracting 2 perfect cubes, the formula is a minus b, a squared plus a times b plus b squared. So there are only 2 signs that are different.
So Connor can't touch the paper now. He can touch the axe.
Now, I want to do number 2 with you because it's just slightly harder. Shh.
I'm worried about Connor's safety. Kayla's trying to kill you.
Yeah, look it. These are Connor killers.
I'm like deathly allergic to peanuts. Yes. Like I could die if I eat them wrong. I just had to decontaminate his paper. Kayla thought it'd be funny to put a peanut on my own.
Kayla.
I didn't know you were
Oh.
You didn't? You just thought it was a 16-year running joke of Connor having a peanut allergy?
All right. Looking at number 2, are these perfect cubes? No. Shh. Are these perfect cubes?
Yeah. Hold on for some reason, don't change it.
No, they're not perfect cubes, right? However, this entire time, have we been checking for a GCF first? No. So in 1 and 2, or this example and then number 1, were there GCFs? No. In this top example, is there a GCF? No. In number 2, is there a GCF? What is it? In number 2, 4, even though it looks like it does not go into 54. Lower. 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 2. 2 goes into 16 and 54. So I'm going to pull a 2 out. What is 16 divided by 2? 8x cubed. And what is 54 divided by 2?
27.
Are these now both perfect cubes?
Yes.
Yes, they are. So now I can use difference of cubes. When I'm using difference of cubes, what do you think my first step is?
Using the A.
Doing what?
Cube root.
Cube rooting the,
A.
what's our A?
AX cube.
Cube rooting 8x cubed. So what is the cube root of 8?
2.
And what's the cube root of x cubed?
X.
X. And then our B, what is the cube root of 27?
9. Wait. 3.
What times itself 3 times is 27? 3. So then all I need to do now is take these values and plug them into our formula. So it's A, 2x, minus B, which is 3. And then it's A squared. What is 2x squared? What is 2x squared?
Oh.
Yes, you need to remember to also square the number. 4x squared. Plus A times B, what is 2x times 3? 6x. Plus B squared, what is 3 squared? And in the future, yes.
Quick question, is that 2, is where 8x cubed, is that like a part of the equation, or are you just writing down it's question 2?
That's part of it. I pulled out a
Just making
2.
Sure, like I was confused.
Yeah, the 2 is the GCF.
Okay.
So, in the future, we're going to have to look to see if the quadratic will factor further, right? We'll need to draw our x, do A times C, and put B in the bottom, and see if we can find 2 numbers that multiply to be the top but add to be the bottom. However, for today, I'm going to tell you that's as factored as it gets. Any questions on this problem? All right, you guys go ahead and do the top example.